Hydroplaning in aviation refers to a phenomenon that occurs when an aircraft's wheels lose traction with the runway surface due to a layer of water, oil, or other liquids. Here's a detailed explanation of hydroplaning, its causes, effects, and prevention strategies. How does hydroplaning occur? First, let's talk about the formation of a water layer. Hydroplaning occurs when water accumulates on the runway surface, creating a layer that can affect the contact between the aircraft's tires and the ground. Next is dynamic pressure. As an aircraft lands, the pressure from the tires can cause the water to be displaced. However, if the amount of water is greater than what can be displaced, a film of water forms between the tires and the runway. Loss of traction. When the water layer is sufficiently thick, it generates a force, dynamic pressure, that can lift the tires off the surface, leading to a loss of friction. This results in the aircraft being unable to steer or brake effectively. Let's explain the different types of hydroplaning a pilot might encounter. First is viscous hydroplaning. This happens when water on the runway is mixed with things like oil, which reduces the surface tension. That makes it much more likely for hydroplaning to occur, even if you're moving at lower speeds or the water isn't all that deep. Next is dynamic hydroplaning. This type occurs when the aircraft is moving at higher speeds, usually when there's more than 1/16 of an inch, about 1.5 millimeters, of standing water on the runway. Basically, the faster the aircraft goes, the higher the chance of hydroplaning. Static hydroplaning. This type actually happens at very low speeds, usually on puddles or spots where water tends to collect. What can happen is the aircraft's weight ends up sitting on the water instead of the ground, and that causes a loss of control. Factors affecting hydroplaning. First, water depth. The depth of the standing water directly influences the likelihood of hydroplaning. Even a small amount of water can lead to hydroplaning under certain conditions. The airplane's tire condition is absolutely critical. Worn tires or those with poor tread can really increase the risk of hydroplaning, since they might not be able to effectively displace water. Speed of the approaching aircraft. Higher speeds do increase the risk of hydroplaning as more force is applied right at the moment of touchdown. And finally, the runway surface itself. The texture and condition of the runway play a significant role here. Smooth and shiny surfaces, like those treated with certain chemicals, are definitely more prone to induce hydroplaning. The weight of the aircraft plays a pretty significant role here. Heavier aircraft exert more pressure on the tires, which can actually reduce the likelihood of hydroplaning. But at the same time, it means they need a longer distance to come to a complete stop. During hydroplaning, the pilot just can't steer or brake effectively, which can result in a total loss of control. This could mean the aircraft might veer off the runway, and that's a situation no one wants to be in. So, when an aircraft can't really apply the brakes properly, or slow down because it's lost traction, it actually needs a much longer distance to come to a stop. This increases the risk of overrunning the runway. If hydroplaning happens during landing, it becomes a serious safety hazard, not just for the aircraft itself, but also for anyone else who might be on or near the runway. How can we prevent and reduce the risks associated with hydroplaning? Proper landing techniques are absolutely essential. Pilots are trained to adjust their landing approach in wet conditions, you know. This might include landing with a firmer impact, just to make sure there's proper contact with the runway. Monitoring weather conditions is also really important. Pre-flight weather assessments can help pilots get ready for potential hydroplaning scenarios, which allows for better decision-making when it comes to approach and landing. And the use of anti-skid systems is another key factor. Many modern aircraft are fitted with these systems, which help maximize braking efficiency even when the conditions are slick. Regular tire maintenance, it's absolutely vital. Making sure that aircraft tires have proper tread and are in good condition really helps to reduce the risk of hydroplaning. By understanding hydroplaning, its causes, and the effects it can have, pilots can better manage landings in adverse weather conditions, which ultimately improves safety for everyone on board. Pilots may, at times, intentionally perform hard landings during wet weather. This is done for several reasons, all related to safety and maintaining control of the aircraft. Shorter ground roll. In wet conditions, a harder landing can help ensure that the aircraft is firmly on the runway and that the wheels are making better contact with the surface. This can assist in achieving the necessary braking effectiveness sooner. Preventing hydroplaning. A hard landing can help displace water on the runway surface more effectively. This reduces the risk of hydroplaning, where the tires lose contact with the runway due to a layer of water, making it difficult to control the aircraft. Improved braking performance is really crucial. By landing sharply, pilots can actually engage the brakes more aggressively. This is especially important on slippery runways, where maintaining stopping power is critical to avoid overrunning the runway. Stabilizing the airplane, particularly in wet or gusty conditions, is another key factor. A firm landing can help ensure that the aircraft remains stable and controllable on the ground, minimizing the risk of skidding or yawing. When it comes to aircraft design considerations, modern aircraft are often built to handle a wide range of landing conditions, including firm landings. So, pilots may purposefully execute a firmer landing, knowing that the aircraft can safely absorb the impacts. In summary, while soft landings are generally preferable, the dynamics of wet weather and safety considerations can sometimes necessitate a firmer approach and landing. Pilots are trained to assess the conditions and make the best decision for landing that ensures safety for the crew and passengers.